All right, so we are out of chapter 7. We're moving on to chapter 8.2. Today's lecture will probably be a little bit of a short one. I'd encourage you to, if you're hazy on any subject that we've studied recently, go back and review that if this is kind of easy for you. So today we're going to start off with roots and radicals. We're going to figure out what kind of numbers can be simplified when they're radicals, and what it means to be a root or a radical in the first place. So the first thing we're going to go over is, what is a square root? So a square root, we should say it in the definition, the number c is a square root of a if c squared equals a. All right, the radical sign, this little kind of elongated check mark, that's what we use to indicate the square root of a number. So recall these couple of facts here. Remember that positive 3 squared is equal to 9. Negative 3 squared is also equal to 9. So the square roots of 9 are plus and minus 3. Right? We don't usually ask for that. But if I ask you for all the roots of a number, you should give me the plus and minus versions. I usually don't, but just keep that in mind, that a positive, the square root of a positive number has 2 square roots. So we call the positive version, we call the positive root the principal root. And that's usually what people use. When somebody says, well, what's the square root of 49? It's pretty rare to hear somebody say plus or minus 7. Darn it, that was our next example. So if somebody did ask me to find the square roots of 49, I could say, well, square root of 49 is equal to plus or minus 7. Okay, in general, if I don't specifically ask for both roots, especially at this level, I wouldn't worry about it too much. Just recognize that that's the way it works. Yeah. So suppose we're asked to find a root for each of the following. And so notice here, I didn't say find both roots. I just said find each of the following, right? And so honestly, I'd accept the positive or negative version, but we're going to do the positive version. So you can always find a square root by just punching it in on your calculator, and I'm pretty much always fine with that if that's what you want to do. So the square root of 225, if I punch in my calculator, is 15. Right? And I'll show you why. So yeah, we could just write equals 15 if we want, but I'll show you why that's the case in a little bit here when we go more over the definitions. So negative the square root of 64, right? The square root of 64 is equal to 8, right? The negative's on the outside of the square root, so negative 8 would be the answer to this. Okay. So if we ask you to find the root of 225, it's totally fine just to give the positive version. You can give them both if you want to, but just the positive version is fine, unless I ask you to find all the roots of 225. Okay, so let's go over just a couple definitions. So a radical expression is an algebraic expression that contains at least one radical sign. The radicand in any radical expression, that's the expression underneath the radical sign. The radicand you will need to know, yeah. The radical expression is sort of almost common sense. Yeah, so the radicand in this first example is x. The radicand in this second example is y squared minus 5, right? The whole thing that's under the square root. But not the 3, because that's out in front. Okay. So now, remember, let's see. That's right. So recall before we go into the next portion, just remember that the square of any real number is going to be positive, right? Like these two numbers here, yeah, they were negative when we squared them, but the positive version comes out, right? So that tells us that it tells us that square roots of negative numbers are not real, right? Because there is no negative that squares to give us, or there is no number that squares to give us these negative numbers. So we can say the square root of any number is not real. So if somebody says, give me the value of the square root of negative 25, you can say not real. Or you could say imaginary. You can say not a real number. You can't say undefined, though, because it does have a definition. It's just in imaginary land that we're not going to touch on in this class. But they are defined. They're just not real numbers, which sounds a little strange. What about this one? Is this number real or not? What do you guys think? And this is kind of a trick question.
No, because the negative's on the inside.
Right? But what if x equals negative 5?
Yes.
Yeah, right? And so, yeah, it depends on x. It was a total trick question. I'm sorry, Joey. I threw you under the bus. No, thank you for responding to that. But yeah, so basically, like, if it's a variable under there, we can't really tell if it's real or not until we know what that variable is equal to. All right. Moving on. Now we go over the definition of irrational numbers, and we've already gone over this one, but I'm going to show you what it means to be a radical and irrational. So just recall that irrational numbers are numbers that cannot be represented as a ratio of integers, right? So things that can't be represented as fractions of integers, right? 2/3, nope, that's rational because that's a fraction, right? Things like pi, that's a very famous irrational number. There's no way to represent pi in a fraction of integers, so that one's irrational. All right, and so when it comes to square roots, just for an example, the square root of 2 is irrational. The square root of 9, however, that's not irrational because the square root of 9 equals 3, and 3 is a rational number. So this leads us to kind of like a rule of determining whether these numbers are rational or not. So the rule basically is the square root of any whole number is irrational unless that whole number is a perfect square. The list that I handed out to you here is the list of the first 50 perfect squares. And so if you're looking at a root that's not on this list, then it's probably irrational, right? And so this list, you can see it jumps from the square root of 1 to the square root of 4, right? Which tells me that everything in between that is irrational. Root 2 is irrational, root 3 is irrational. There's better ways to tell if things are irrational, but that's kind of how our first definition is going to go, right? If it's not a perfect square, then it's probably irrational. Okay, here's just kind of like a list of, this is a list of the first 25 square roots, right? This isn't the same as the list I gave you, but you can see the perfect squares really don't pop up all that often. Right? They actually start to spread out as you get larger. And so there's a whole lot more irrational square roots out there than rational square roots. The rational ones are just the ones we can simplify to a regular integer. So suppose we're asked to classify each of the following numbers as rational or irrational. So first of all, I say, okay, the radicand, that's equal to 10. And I ask myself, is 10 a perfect square? Right? Not really. It's not a perfect square. Basically, there is no two integers that you can multiply together to get 10. Right? The square root of 10, if I punch it into my calculator, that gives me something ugly. That gives me 3.16 blah, blah, blah with a bunch of decimals. So I can say, no, this is, it asks us to determine. So I can say this is irrational. However, this next one, you can see the radicand is 25. 25 is equal to 5 times 5. So yeah, 25 is a perfect square. This is just equal to 5. And 5 is rational. And I mean, you guys are at a pretty good advantage here, especially when I go through this on the exam, because honestly, when you punch these into your calculator, if you come up with a big decimal, it's just irrational, right? And I'm not gonna, I won't look down at you for doing that. That's totally fine if you want to do it that way. This one, the one on the bottom here, right? Negative the square root of 9. Remember, the negative is on the outside of the square root, so that's okay. If the negative were inside, then we'd have issues. But the negative is on the outside, so this is just equal to -3, and that is rational. Just another little, just another little kind of thing you might run into. Fractions that can't be reduced that have an irrational number in them are still irrational. And so if I say, well, 2/3, that's rational. But if I say 2 roots 10 over 3, that whole thing is irrational because it contains an irrational number, right? And so an irrational number stuck in a fraction, if you can't simplify it, that makes the whole fraction irrational. We went over the properties of irrational numbers, right? I told you guys about infinite monkey theorem. Pretty sure I did. Yeah, it's about the monkeys on the typewriters. I know I told you guys that. Yeah, okay. All right, so I won't go off about irrational numbers again. You're welcome. I love irrational numbers, though. They're super weird, super interesting. So if you guys have one of these TIs, I'll show you how to calculate the square root of 10. If you have a different calculator, make sure you learn this and figure it out and get good at it. You don't want to be in a test situation and forget how to take the square root of 10. So on this calculator, all I would do is I would hit this second key so I could access this little square root sign. And then after I punched in the square root, I'd hit 1, 0 for 10. And close off the bracket. And so I'll show you what that looks like on the next screen. So on my calculator screen, this is the way that shows up, and this is my result. If you don't have a calculator with a good square root button on it, or you're worried about getting one for the next exam, you can see me and I'll make sure that you get something that works. I don't, punching in a square root, though, and just calculating it, that's not quite what we'll have on the next exam, but you might have to calculate some square roots. So just so you know, at least on this one, right, you can punch in a bunch of things underneath the square root on your TIs. You do that by just hitting the square root button right here, and then punching everything in and closing it off with brackets, right? And so I can punch this in all in one line and calculate it if I want to. Okay, so that is square roots in your calculator. Like I said, make sure you kind of know how to do this stuff. And if you're using your phone for a calculator, make sure you know how to find this on whatever calculator you're going to use for the next exam. Okay. Square roots and absolute values. So this is kind of a conceptual thing that is definitely you're gonna need it for next year, but I'm not gonna be a big stickler about this on the exam. It's more conceptual. So let's just take a look at two cases. This first case, we take a square root of 5 squared, right? 5 squared is 25, square root of 25 is 5. This second case, we take the square root of -5 squared, right? However, a positive 5 still pops out the other side. Right, because it gets squared in the middle, it sort of erases that negative. And so essentially the rule is, if we use both of these operations together, we basically we pop out a positive version of the radicand. Remember, the radicand is what's underneath the radical. And so this is the official rule right here. It says for any number a, the square root of a squared is equal to the absolute value of a. And remember, the absolute value is just the positive version of a. And so on both these examples up here, I can say, yep, and this is equal to the absolute value of 5, right? This is equal to the absolute value of -5. And basically, you really only need to worry about this. It'll probably be next semester before you really start worrying about this particular concept. But it will be in there. So basically, if we were worrying about this concept a little more this semester, and I said simplify this, you would tell me this is equal to the absolute value of 3x. Right? But what I'll say is that on most problems, there might be a few in your homework that ask you to do this, but on most problems from here on out, we're assuming that our variables are positive, which means we don't need to do this. So like on this following problem, I've said we are assuming that our variables represent non-negative numbers. So now that we've made that assumption, we don't need to put absolute values in anymore because there's no chance that this was negative to begin with. So I can just say this is equal to 8x. Right? And so notice what popped out there. It's what's written all the way on the inside. Okay, on this next one, just because it's a binomial doesn't change anything, right? Whatever is inside the brackets that are squared, that's what pops out, t plus 2. We don't need the absolute value signs because we assumed all the variables were non-negative. And on the upcoming exam and on the final, I don't take points off for leaving out an absolute value sign. I really don't give you much opportunity to. I don't mention much about the positivity of variables. Okay, but just notice on this, let me show you kind of how this sort of aligns with what we're doing with other square roots. So the square root of 25, we can rewrite this as the square root of 5 squared. Right, and so that's it. We rewrite it, and so the 5 is what pops out the other side. That's why. That's one of the other reasons why the square root of 25 is 5. Okay. So we're going really fast here today. It's going to be a quick class. So this is an example of an evaluation problem. This is the type of problem that you might need a calculator for when you're on the exam, because you might have to put in some weird numbers for this one. So this problem says the attendants at a downtown parking lot use spaces to leave cars before they're taken by long-term parking stalls. The required number n of such spaces is approximated by this formula. N equals 2.5 times the square root of a, where a is the average number of arrivals in peak hours. They want us to find the number of spaces needed when an average of 43 cars arrive during peak hours. So they want us to say what happens when a equals 43. So we just write this out. We say, well, n is equal to 2.5 times a times the square root of a. So we have 2.5 times the square root of 43. This is definitely something I'm going to have to put in my calculator. So 2.5 times root 43. That gives me, and I'll use my squiggly lines because it's not exact, that gives me 16.393, and then there's a bunch more decimals after that. So now, because this is a word problem, we have to think a little bit more about the problem when it comes to our answer, right? So they say, find the number of spaces. We're not going to give them this number. That's crazy. They'll fire you, right? And so if we're worried about having the correct number of spaces, what should we make this number, right? And we don't want to run out of spaces, basically, right? Think about that, right? We don't want this to be lower than the expected number because then we're going to be short a car. If anything, we want it to be above one number. So we say 17 spaces for this one. We round up. Okay, if the average number of cars arriving per hour was 35, well, in this case, A equals 35. So that's a little different. Now we have N equals 2.5 times the square root of 35. And that gives me roughly 14.79. So we would say 15 on this example, right? Because we don't want somebody to have 80% of a parking spot, unless they have a really small car, maybe. So when it comes to word problems, at least on this section, a lot of them, at least one of them, I should say, will be an evaluation problem like this, where you're plugging things in and you're seeing what the results are. Okay. So now let's just go through a few more problems just to kind of cement this stuff in, and then we're out pretty early on this one. So does anybody know what the square root of 420? Good. It's okay. You can say it. You can say it, right? And so I could either write the square root of 400 equals 20, or if I wanted to put an intermediate step in, which I'm not demanding this on your homework, I could write it as 20 squared, right? And so that equals 20. This one here, remember, it's okay for this to happen, right? The negative sign out in front, that's totally fine. It's the negative sign inside that's bad, right? And so this, I think I heard somebody say it already. Yeah, negative 10 on this, right? Square root of 100 is 10. The negative sign's on the outside, so there it is. Yeah, I think I heard somebody say it already, right? When we have the square root of something squared, it's just that thing that pops out, right? Since I've already said kind of like, we're not going to really worry about the absolute values. We're assuming these variables are positive, so I don't need to put the absolute value signs. So here's a couple examples that are kind of going to get us ready for tomorrow's class. Just a little bit of conceptual stuff, right? So this first one here, this is obvious, right? The square root of x squared, well, that's just equal to x, just like the formulas say. But this one, it's not quite written like that. What we need to notice is that we can rewrite it like that. So what we could rewrite this as is the square root of x squared squared. Right? Yeah, I know it seems goofy, but that's really the way it is. Yeah, and so you say, okay, that's what I pull out. It's the x squared. Right? I can do this same thing. Let's do one more here. If I wanted to find out what the square root of x to the 6th is, yeah, you got this. You know where this is going. I just rewrite this, and I say, well, this is x cubed squared. So what comes out? It's whatever is inside. So it's x cubed. And something that you guys will notice, this is a rule that we'll learn tomorrow, is that when you have an even square root like this, what pops out the other side is exactly 1/2 of the exponent. And so the square root of x to the 4th is x squared. The square root of x to the 6th is x to the 3rd. The square root of x to the 100th would be x to the 50th. Yeah, so it's just 1/2. So it's a real simple kind of rule that goes along with that. Are there any questions? Dude, this is like the quickest class ever, isn't it? All right. I won't even thank you guys for your patience because it didn't take any to get through that lecture. No, thank you guys for your patience. And